Greetings. Welcome to Geometry Puzzles, a series of videos on problems and puzzles in geometry. This is problem number 8. Three circles centered at A, B and C are tangent to each other and line L. They are placed as shown in the figure. Let A, B and C be the radii of the circles centered at A, B and C respectively. Prove that 1 by under root C is equal to 1 by under root A plus 1 by under root B. Fantastic question. So how do we prove this? One way to prove this is as follows. We make a few constructions in the diagram in question, and our proof will involve three major steps. The first one will be that we have to show a1 c1 square is equal to 4ac. c1 is this c1 over here. a1 c1 square is equal to 4ac. This is the first thing that we will prove. Then we will show that b1 c1 square is equal to 4bc, and then we will show that a1 b1 square is equal to 4ab, and after we have proved all these three things, then we will use a1 b1 is equal to a1 c1 plus b1 c1 from the diagram. a1 b1 is equal to a1 c1 plus c1 b1. So we prove these three things, and the fourth statement will follow what is asked. So let us begin. Let us prove a1 c1 square is equal to 4ac. Now, looking at this diagram, we notice that a1 c1 is is equal to c2c. This is equal to this. Perhaps I will use a different paint slide for these three statements. So for a1 c1 square, let us have a different slide over here. This is what we are going to prove. Alright, so a1 c1 is equal to c2c, opposite sides of a rectangle, and further we notice that this point and this point are collinear. These 3 points are collinear. It is a property of two circles that are externally tangent to each other. So there exists a line which is collinear with the 3 points, and we can draw the line as follows in the following manner. So in triangle AC2C, we have AC square is equal to AC2 square plus C2C square, and C2C is nothing but A1 C1. And A1 C1 therefore square is equal to AC square minus AC2 square. Now AC is equal to the radius of circle with center A plus the radius of the circle with center C, and AC2 is equal to AC2, this length is equal to this length, which is A, minus this length, which is C, radius of the smaller circle. So A minus C is what we have. So we put this value of AC and AC2 over here, and we get the following. So what we will have is A square and C square will get cancelled, and we will have 2AC minus 2AC, which is 4AC, and therefore A1C1 square is equal to 4AC. So the first part is done. Moving on to the next part. We will now show that B1 C1 square is equal to 4BC. This is what we are going to prove. So where is B1? B1 is here, and C1, B1 C1 is same as C3. So B1 C1 is same as CC3, and CC3 is equal to A2C, CC3 square is equal to A2C square minus A2C3 square, Pythagoras theorem. So again, I'm sorry, there is a small correction over here. Let me not skip steps. According to the Pythagoras theorem, what we will have after connecting B and C is the following. And from this we have CC3 squared is equal to BC square minus BC3 square, and CC3 square is nothing but C1 B1 square or B1 C1 square. Now BC is equal to B plus C, and BC3 is equal to this length minus this length, that is to say B minus C. So we put the value of BC and BC3 into this equation and get the following. Again we notice that B square and C square will get cancelled, and you will have 2BC minus 2BC, that is to say 4BC. B1 C1 square is 4BC. So one more part is over. Moving on to the next part. Here we will prove that A1B1 square is equal to 4AB. Now again we draw a line like this connecting A and B, and we notice that A1 B1 is equal to A2. And A2 can be related to AB and A2B in the following manner. Pythagoras theorem. Further, we notice that AB is equal to A plus B, and BA2, this length is equal to this length minus this length, that is B minus A. So if we put the values over here, we get A plus B whole square minus B minus A whole square, and again A square and B square will get cancelled, and you will have 2AB minus 2AB, which gives us 4AB. And A2 is nothing but A1 B1. So A1 B1 square is equal to 4AB. Hence this is also proved. Now, since all the three are now proved, consider this equation. A1 B1 is equal to 4AB under root minus under root is immaterial for now, and we ignore, that is A1 B1 square is equal to 4AB. So A1 B1 is equal to plus or minus under root 4AB. We ignore the negative sign because the lengths are positive. So under root 4AB is equal to A1 C1, which is under root 4AC, plus B1 C1, which is under root 4BC. In this equation, if we cancel under root 4 from both the sides, we get AB is equal to AC plus BC under root. And we multiply this equation throughout by ABC under root. Sorry, we divide throughout by under root ABC. So we divide throughout by under root ABC. And this then becomes 1 by under root C is equal to 1 by under root B plus 1 by under root A, which is what is asked. Hence proved. Thank you for watching.